So the motivation or the reason I wanted to prepare this was because things are changing so rapidly around us. In this whole world of like software and writing software and all that, there's been so many different times when a huge overhaul has occurred. I started off as a Java developer, and I remember the time when we used to package our Java code bases into war files and jar files and then execute those to production and things like that. And whenever I talk to a lot of people who attend meetups these days, especially the younger crowd, they think that Java developers from the Jurassic period, they're almost extinct, but Java still powers huge parts of the internet. It's not gone, it's still there, it's thriving, it has a very lively ecosystem. It's really doing wonderful things and enabling a lot of things on the internet. Just don't write it up altogether. But also, even back in the day, there were so many things. I remember Hyperlink coming out, I remember Spring Boot, I remember all of these fun Java things that and mathematics get very excited about, some person talk about it, things like that. And you know, it was like we discovered a lot of new things back in the time. And the more recent massive changes have been around containers and Docker really changed the world around how we package apps and how we book distribution and how we were really thinking in terms of taking applications written in any damn language and putting it in a container and then it was ready. It didn't matter. PHP, it didn't matter if you were like a hipster writing TypeScript. I don't know if anybody writing TypeScript, but somebody, because all of this mental behavior around microservices, where the minute you Google microservices, first thing you say is, oh, you can let your teams write services in any language they want. I don't know who decided to put that advantage out there. It's very hard to tell people like write in these 4 or 5 languages that you don't learn a new language every time you want to write a new service. So, but anyhow, that is the world that we live in, and we're subject to massive changes. And this whole containers and now Kubernetes thing has become so much ingrained in my head that I don't buy washing powder anymore. I buy pods. What are these called in your house?
Containers.
Have you heard? Everybody calls it Java. Yes. Now we call it containers because we want to sound bad. Yeah, so containers and Kubernetes is so much a part of our life. And every time I get mad at my kids for scribbling in the house, it's like error messages come to mind more than anything else. In Telugu, Geetalu, all of it has turned into like Kubernetes in my head. So this talk is also about changes that are happening all around us, changes that are very difficult to talk about because these days if you have to get a talk accepted at an event, it has to be about AI and ML. And unfortunately, I have never had the time to talk. What I do is the system. I was always stuck in my desk, making sure that the infrastructure that I was responsible for the stuff was running, and I was not getting complaints. And so around some, AI and ML, and in a world that's dominated by infrastructure in the form of containers and container orchestration, and all of it enabling wonderful things, including AI, which is only 17 minutes away. The whole notion of writing at this of effort for machine learning, for AI, which is very data intensive, very big, not the easiest to manage, but very important in terms of wanting to deliver something, is really making a difference in terms of how infrastructure people are thinking in this era or this time of AI. So welcome to my talk, everybody. Thank you so much, Hyderabad, for having me today. This talk is about what you can do as an infrastructure person in the era of AI, but based on technologies that you're already familiar with and based on working paradigms that you already know. So the talk is titled Everything Docker Can Do, KitOps Can Do. So KitOps is You already know that Shiva said this about 15 times that I'm going to talk about KitOps. So KitOps is a tool that's a part of the CNCF ecosystem, and it adopts the container first mindset to apply for ML workloads and ML pipelines. And so as I was learning this, what I realized is that a lot of the GitOps terminology and paradigms and everything borrowed very heavily from the Docker. And so this talk is designed to be here's what Docker is and what it needs to bring in process. Here's what GitOps is and what it does. And so you can really understand what GitOps is doing if you understand what Docker does. And people here are familiar with Docker, right? Let's know
Yes.
if it's no, you're at the wrong event, why we get to so long. Okay, you can still stick around for the if that's interesting. But again, by way of introduction, my name is Ram. I work full time at the Linux Foundation. I do open source for a living. So all of this really matters a lot to me. And it's been such a pleasure just taking the open source story to every corner of the world, every corner of the country, and getting a lot of feedback from people about how they're using the stuff, where they're using because of this and generally sharing stories and broadening the horizon of open source. Now, yeah, I mean, I'm not a CKA, CKE, COVID developer expert, whatever, Amazon developer expert, nothing. I'm not educated in anything at all. It's probably makes me a least qualified teacher, but then Shiva is backing me up today, and a lot of the stuff is getting me carefully. And hopefully, it comes across as informative, and you learn a little bit from this. Um, if you do, credit you to me. If you don't, I blame you. Yeah. So let's talk about data, and that's the bedrock on which this entire surface of ML, AI, and all of it is formed. So data is what everybody likes to speak about. Data is what you see, and there's so much data around you, you really don't know what to do with it. And then unless you have like tons of data, it's really hard to figure out what you want to do with AI and ML. Now, there's also a tiny other thing that I wanted to add. I was raised in the city, so I love Hyderabad. I love it. There's so many places that just come to mind when I think of the city. And so as I was making this presentation and when I thought of data, and then that led me to research a little bit about data lakes, which is where people derive a lot of their things from. And then my favorite lake came to mind. Yeah. And that's in my mind a data lake is like 1 a.m. yesterday. And that's very common as of PhD. And it's the only person in the company who knows Python. Right? Okay. Right? So that's what came to mind. But the idea is there's now an entire life cycle built around this data lake where you do all kinds of stuff. Like you prepare data in order for it to be processed. You then extract features from all of this data and prepare your vessels and tokens and all of that fun stuff. And then you use all of this data to train your neural networks and things like that. And then finally, a model will emerge out of the data that you use. And then this model has to be served, which is what it needs to productionize your AI or your ML work. Right? So all of this, like I said, it needs the data. And then there's so many pieces that get added as you go along. And so there's an inherent challenge. How do you keep all of these things together? And that's where KitOps comes. KitOps is a tool that was designed in order to borrow heavily from the container ecosystem because, copying is or being inspired is the easiest way to carry the ecosystem forward. And so the contributors of GitOps and the code maintainers, all of them decided to take this quote unquote container first approach in order to design how you're going to manage your ARML code. This GitOps is very simple. If you go to the website, it will have this line at the same time because I know everybody's a little lazy. But also The idea is you keep all of these artifacts together in one place and not let them scatter around for your AI ML. They advertise themselves as a missing link in your AI pipeline. That's a bit of marketing, I think. So I did that. But it's also like a good open source DevOps tool that is specifically focused in the ML. So I would define it as a good ML output if that's what you want to call yourself this week. Last week your platform is here, the year before that you were SRE, year before that you were kind of something. And a long time ago you were stress admin, I don't know, man. Whatever you want to call yourself. But GitHub and your ML or stuff go well together. I was very tempted to put out my favorite combination in the world. Right? There's nothing that we go to Somalia biscuits and a couple nice warm running. So the challenge again does not limit just to shipping all of these different aspects. But it's also about packaging them as a field or distributing. This is looking at this is marketing and maintaining. So there's so many different challenges in the AI ML world, just when it comes to doing all and managing all of these artifacts that are required. And despite being like a tech community who are always hard at work for finding out new things and discovering new ways, we stop at creating standardized ways. Okay. The first thing we suck at is documentation. We never document aspects because we don't want the next person to follow what we did. And that kind of job security, good performance reviews because you're the only one somehow who knows security. But also it's like a shame that this entire community. Yes, but the point is when AI and ML started to take off and then we were doing all of this one AI ML stuff, there was no way for us to converge on a standardized format. And that's changing a little bit. And I'll tell you how. So in the cloud native ecosystem, there is I don't know if I got the entire name right because it's using AI somewhere. I was too tired to look it up. So the cloud native open model spec that defines how you should create a cloud native, define your AI ML artifact into a single larger artifact that you can then ship to wherever you want to, and then it's easier to maintain, easier to distribute, easier to just operate on. And so the CNCF owns the specification, and then there's tons of people who are trying to implement this individual specification as the way they want to maintain their models and now that's again like all CNCF initiatives and projects, this is also open source. So if you want to participate in the definition of what an open model means and how you want to define the future of how you use it, I highly recommend participating in this forum. Model is what KitOps is based on is an abstraction that is introduced by this community. And then they say that if you keep all of these things together, and through that will emerge a single good cohesive unit for packaging. Speaking of these, any HTML application, in my opinion, comes with four very important components. There's data, there's code, and basically set there's model that you require in order for doing anything useful with AI. And then there's a little bit of config flag notice how I left out documentation because even I suck at it when it comes to presentation. The point is, all of these four things put together is what really constitutes a good AI. And every time somebody says four things, I can only remember the secret packet from when I was young. Data integration, the only ones all the auto drivers use. And Hyderabad, this being Hyderabad, I had to bring it up. But basically, without these four entities present, it is near impossible to have a functional AI or ML art. And then I hope the rest of the crowd will agree. So back to model. Model kits are like the definition that the KitOps / open model spec community within the CNCF is trying to define in order to have a more cohesive packaging, have a clear artifact that you want to try. Like a maker, everything you need to change the word is in there. Right? The next problem that I wanted to highlight is existing data for packaging. All of these AI artifacts are not reproducible. What I mean by that is it's not easy to repeatedly create an automation around all of these artifacts because models are somewhere. Your data scientist put their code in Jupyter notebook sometimes. Maybe one data scientist went through, I don't know, some event somewhere and said, oh, people are putting code in GitHub, let's do that as well. So then some code is in GitHub somewhere. And then a lot of conflict is in some other Google Drive that you want. And then somebody decided to put all the data sets on an S3 bucket that everybody forgot. So very soon, a lot of the AI stuff can be very fragmented. And so, because it's so fragmented, if you 50 pieces, it's almost impossible to find a reproducible way to create a single artifact in order that you can deploy. You get then like you guys said 7 times in this talk. KitOps adopts the security first approach, then you can, in addition to just putting all of this together, you can add signatures to the package so that you know if anything has been sampled and if this is a really trustworthy artifact that you just pick up and start. So all of this together is what we're going to look at in the next however many minutes, like I said. And compare it. So here's what we know about Docker, and here's how we're going to package our. Alright. So for a lot of us, Docker and containers are used interchangeably. For somebody very pedantic like me, that's not. Containers are significantly different from Docker, but it's like photocopy versus Xerox, right? How many people know that? So because Docker is so pervasive, I'm going to pick out Docker as the tool of choice in order to communicate a lot of these data. Yes, the next begin is a mental model. Back in the day when I don't want to seem very old, but back in the day when I started, so maybe I was going to start, right? Everything was thought of in terms of machine. So you had like rooms that were big as the stage, and then you had like racks that were big as a fridge, right? And in the room was like a fridge, to be honest. I don't know if you remember the time, but in a data center that you had to maintain on your devices, it was a very, very old room with very, very old computers. And then you had to maintain all of these in terms of machines. And then we moved to a VM centric. Then people started to ask for machines, and machines were made in software as opposed to somebody going and installing a physical rack, configuring the networking, and then giving you access to it. You could just open a subroutine and then it will come back with, hey, this is the ID for your machine, the password is admin123. Please remember to change it after you log in. Right? So that was the VM based one. And then we moved to a container centric world where, like I said, all the work that we're trying to do are done as containers. And so we're looking at what is this infrastructure going to look like when we're working heavily with models, with AI and ML models. And how is it going to change? What is the definition of a machine? What is the definition of a workflow? And so we want to maintain some kind of continuity with the containers world. We need that model. And that's the goal. So once we decided on that, like everything in this community, we decided to create a new standard. And so we adopted something that exists. So OCI here stands for, okay, let's do meaningful. Anybody, OCI full form? Never too late in using, but we will want to have that. That's what it is. Open Container Initiative is what OCI stands. OCI basically was somewhat different from containers until that point, but it was also a continuity of the same thing because there's two things that we wanted to do with containers. We wanted to have For example, you have infrastructure that's got whatever Amazon, Amazon users, and you had like regular users, right? And if you wanted a different mechanism, you didn't want to go in and actually specify different containers and maintain different pipelines. That OCI containers were built to be capable of creating to these requirements without having the operators do something else. That is, depending on the endpoint to which you're going to publish, OCI containers were capable of handling cases that were not just a single binary type, but were had like multiple binary types, and because you can address them as what is known as content addressable ways, you can have them deploy the right kind of release for the right kind. So two things that OCI changed, two things that you need to remember that OCI changed. One was being content addressable, and the second was being able to group related. So much like that, you all know the Docker pull command, right? You can run a quick pull command. Yeah, fortunately, I'm going to run it. And now, just as you did Docker pull, I don't know how much is visible at the back, but thinking beyond this, and my eyes are starting to. So, you do it is a CLI for GitOps. It allows you to, it is a CLI that allows you to do all of the operations that we talk about. It is the individual command that we're going to use. And then this is the remote repository from which I'm going to do the pull. Okay, so just like you do Docker pull some image for the data, blah blah blah, you can do a quick pull image, images, etc. So what this will do is this will trigger a full operation, and then whatever is referenced inside this particular model kit, which if you remember from 5 minutes ago, contains the model, contains the data, contains the configurations, and contains the code. So all of it packaged into one. It's going to pull everything and make it available for you locally. Okay. Now this will almost take as much time to download the full internet. So I'm going to cut this operation short. What I do have is a bunch of different where I'm obviously we tried this morning, and I can show you some things that are already available. So I have just a couple of data. Okay. What I can do with it is I can create I can create or I can initialize a model. Yeah. So model will either contain, and the model kit can contain all of the things that we spoke about, but just contain a subset of these. In this particular case, the model kit is only going to contain some this check. So I'm just going to give it a name. So all the from this previous model, so if you look here, it basically gives that definition for the kit file. So just like a Docker file, you have what is known as a kit file, and this was just generated on the screen. Okay? So that kit file basically has information about these two data sets that are present inside this module. Okay? So that's basically what it is. Now, your module can be as simple as this, or it can be as involved as having all. So this is a much larger sort of code base, and we can do the same thing here. So if you remember, if image and current directory will then ask you questions. And then you basically fill the same thing. And now this kit file is generated 1552. If you're paying attention and watching timestamp, this kit file now contains code, doesn't exist, some docs, we found the README file and things like that. We found a lot of different models. So it grouped all of those models together, and we gave the package a name, and basically created this zip file that you can now use to find out all of the stuff that we. And then there's a quick pack instead of like a download rating. There's a quick pack that you can use in order to create the package for this document, etc. And then there's other things that you can do. So, and a quick illustration of what we just saw, there's an OCI registry, you do a quick pull command, and then you get that into your Kubernetes cluster or container content, and then it basically functions. And I'll show you this in a demo in just a bit. So that's what it is. Very similar, you can push. So you Docker push, right? So once you create a container, you run like a Docker page, and then you push it to a container registry in order to pull it from there at a later time. So that's what it is. So you have some stuff that we just saw. You can do build a kit pack into a single model architecture based on this, and then push it to an OCI registry. The other thing I like is the cTENcf. So cTENcf will allow me to inspect stuff that is here, but also stuff that is not. So I'm going to choose the same remote repository from before, and then I'm going to run a cTENcf on that. And so we can get all of the metadata information that your remote repository about model artifact, and then it will show us what all is in there. So if you want to quickly query what's in a model or what's in a model artifact somewhere before, you can use then the list, which is basically like Docker PS. This it will give me information about all of the model kits that are local. Then there is kit remove, and it will basically like just like a Docker remove or a Docker remove stuff. And then it also has the ability to log in and integrate with remote
Customer.
artifact repository or container registries, which we use as model artifact. Now we could do a Docker demo, but my man Rohit just take it here. Basically, the demo I had was a bunch of like Kubernetes clusters that were running these models that I got from the remote repository. So what it is basically very simple. So if you look at this Kubernetes cluster, this is the definition for being able to deploy this model as a pod. And then this is the model that gets deployed. And then I'm running this both local cluster. This is my local cluster. If you notice, it's the sign here. And then this is a remote distribution that I have, and it's running these models on there. So it's basically a very simple way to create something as a pod and then make use of it to run it on Kubernetes. And the last thing is, just like you sign your Docker container with a signature, such as store, etc., you can do the exact same thing with model artifacts. So I'm not going to the architecture diagram because you know why. If you like what you've heard, if you want to focus on security fix, there is a Monday event for KitOps. It's not as expensive as KitOps. So if you are in the business of security, you like what you see, I highly recommend you coming to the event. And then this entire sort of KitOps ecosystem, minus open source, is backed by a commercial company known as Cloud Foundry. They do a bunch of like the commercial. If you want to adopt KitOps, there is commercial support available for it. So thank you for being such a patient audience and a bag into a very long way. Thank you organizers for having me. Thank you sponsors for the state, for all of that. It's been such a pleasure. This is me on social media. Don't hesitate to say hi, ask questions, whatever you want. Thanks for coming and hope you pick up a thing or two from my